Okay, I wanted to go ahead and work through some more problems because we had so many hard ones. I just want to make sure you see that the idea behind completing the square is not as hard as it might seem because we just had such hard problems in classes. Okay, so we complete the square. That's what we're going to do. The reason we complete the square is we want to change this. This is called general form in your book. And we're going to change it to what most books call vertex form. And vertex form is when you have it written like this. It's got a perfect square in it. And the reason we like vertex form, there's a K there on the end. It's just not showing up no matter what I do. Okay. The reason we like vertex form is that this H and this K is our vertex here. So that's one of the reasons we change it over. Another way that we can use completing the square is to actually solve equations. A lot of people don't like the quadratic formula because they find it tedious, so some people will actually complete the square to solve. I don't know that I would recommend that over the quadratic formula just most times, but it is good to see that you can use it that way also. So here we go. If we remember what I do temporarily, remember f of x is the same thing as y. It's just a different way of writing it. F of x is just function notation. What we do when we complete the squares, we're going to set it equal to 0. Okay, we set the equation equal to 0 temporarily. Setting y equal to 0 temporarily. And then we move our constant to the other side, as we're going to try to create a perfect square on the side that has our x squared term and our x term. Now what I do is I'm going to add half of the b term. Remember the b term here, I could label it up here, ax squared plus bx plus c. The b would be a positive 8 here. So I'm going to take 8, I'm going to divide it by 2, and I'm going to square it. And remember what we're doing is we're adding b over 2 squared to both sides. Now I could write it that way on the other side, but it might be just as easy to simplify it. Since I've got it written down, I can see what it's supposed to be. 8 divided by 2 is 4, and 4 squared is 16. So I'm going to just write it as add 16 on the other side. Okay. Negative 6 plus 16 is 10. And then we have x squared plus 8x plus 8 over 2 squared. But remember, the reason I did that, and we've multiplied this out in class, I'm not going to take the time to do it on the video just because you only fit so much on a video. But the reason we did this is we wanted to create a perfect square binomial. Okay? And when I've added this b over 2 squared to each side, what I have created is x plus, and then the thing that goes in, well, I shouldn't have even put the plus yet. It is going to be plus in this case. But whatever's inside this parentheses, this is 8 divided by 2 is a positive 4, so I'm going to have a positive 4 that I put over here. If it had been negative 8 over 2, I would have had an x minus 4 instead of the plus 4 there. So whatever's in that parentheses, the b divided by 2 is what is your perfect square, okay? Now, if you kind of notice, in a minute I'm going to move this over my equation, but just come off to the side for a minute. Let me show you the advantage of what you've got here. Right now, it would be really easy for me to find my solutions or my x-intercepts because I'm going to recopy this over on the right-hand side. Remember, I set y equal to 0, and where y equals 0 is where my x-intercepts are. So the good thing about this is right now I could go ahead and make my equation. I'll go ahead and do that, but remember, we're going to come back in a minute. We're going to find our solutions, and this is right here is where I could have stopped to do that. Let me go ahead and do the equation first, since that was what we started out to do. We are trying to find it in this y equal a times x minus h squared plus k form. Okay, now if you remember, when we're trying to find the equation, what we do is we go ahead and move the 10 back to this side. Do not try to combine that negative 10 with that 4 in that parentheses. PEMDAS says you got to get everything out of the parentheses and simplify it before you can even put that negative 10 with any other number that might be there. So now I have 0 equal x plus 4 squared minus 10. And remember, then the last step was, okay, well, remember how I temporarily set things equal to 0? Well, I'm going to go ahead and change 0 back to y. It's kind of doing a little switch in, switch out thing, and when I've got the value there that I want to have. Now, here's what's great about this. If I wanted to compare this to the parent function y equal x squared, which you could look at that on your calculator and look at it, because the number up front is just the invisible 1, that's my a term, this is going to be the same width as the regular old y equal x squared function, the simplest one of its type. The thing about it is it's going to have a different vertex. The vertex of the parent function is 0, 0, but my vertex here, I can figure it out if I write this form of the equation underneath it. Now, I want to find out my h and my k because my vertex is the h and the k. Okay, so let me come over here. Vertex, I'll put it over here just so I have room. Now, what's my h? If you look here, here's your x's. Here's, a minus. I have a plus. So let me change my plus into a minus so I can clearly see what I have here. There's my x. Now, here's a minus. Oh, my h is a negative 4. My x-coordinate of my vertex is a negative 4. Now the k, remember it's plus k, you could look at this as plus negative 10, so my k is negative 10. And basically what we kind of finally see is a pattern going on here, is that when you look inside with the x, that was a plus 4, that means the number inside of the parentheses with the x, it always is the opposite of the way it just looks when you look at it. It looks like you'd think your vertex might be positive 4, but it's really negative 4. And on the end, you just take the sign of the number for your k. Since that was a negative 10, my k actually is a negative 10. It's the way it kind of looks on the end. So now, in a minute, we'll go graph this, but I've got my vertex. Now, let me show you how we could get our x-intercepts really quickly. Let's go back over here where I had just made a point to say, listen, this right here is very helpful. If I want to find my x-intercepts, I could go and use the quadratic formula right now if this doesn't factor, and this one doesn't factor, so I'd have to do that unless I go, oh, guess what? I could find it using this method, because here I've got my x and it's squared. I can kind of solve for x here by square rooting both sides, and every time you square root, you have to write a plus and a minus down every single time, no matter what kind of problem you're doing, because two things square to get a positive 10, square root of 10 times square root of 10 and a negative square root of 10 times a negative square root of 10. When you square root, there are two roots there, okay, two things you've got to do. So the square root of x plus 4 squared is just x plus 4, and that's equal to plus or minus square root of 10. Now there's two equations I got to do here. One of them, and I'll do it in green, is x plus 4 is positive square root of 10, and the other one is x plus 4 equal negative square root of 10. There's two answers here. So I subtract 4 from both sides. I'll go ahead and just do that on both equations. So x is equal to negative 4 plus square root of 10, and x is equal to negative 4 minus square root of 10. Okay, so that's not showing up very well. Let me kind of drop it down here. Negative 4 minus square root of 10. Okay, so those are my x-intercepts. Now, if I'm going to graph those on a graph, I'm probably going to go plug them into a calculator and find out what they're close to as a decimal. But these are our exact x-intercepts, and you want to leave them exact, because in real life, when you use math, you use it because you need some detail, some really good, solid, precise numbers. And again, I use this example in class. If, let's say, square equations can be used for, they're parabolas. So, I mean, you could look at it possibly like this, though it may not quite be this simple in real life, but the idea still holds true. If you were going to send somebody to Mars, okay, and let's say it's you, and you're climbing in the little spaceship, and they're going to send you to Mars, and they're going to use a parabola maybe to help get the, your trajectory right to land on the right spot, because you want to hit Mars. You don't want to end up floating off in space, lost in space, okay, like the film Gravity or something. All right. So you want to make sure that you've got accurate calculations, and you think about all the miles that you would have to fly to get to Mars. I mean, I'm guessing it's millions of miles. I don't have that right off, in front of me or anything. But when you're talking about that many miles and you have calculations, that's going to mean that just going out to one or two decimal places is not going to cut it if you want to be accurate. You need tons of decimal values out there for preciseness. And since you don't know, you know, how maybe somebody's going to take this calculation and do something with it to send you there. You want to make sure you got the exact answer so they can get it as precise as they need to do so you can land where you're supposed to. All right, so if I want it now, another thing that you're asked to do on these equations before we go try to graph, and I may run out of time on the video, but we're going to see, is find the y-intercept. Well, the y-intercept, I could have found it right off the bat. Go back up here to this equation I just circled. I'm circling up at the top by the number 20. The number on the end is my y-intercept. And remember, I'm not going to write things just as numbers anymore. I'm going to say, well, the y-intercept happens when x is 0, and it is the number on the end. It is the c in the general equation there. It is 6. So my y-intercept is 6. I ran out of space over here, but with my x-intercepts, I would write those as x is negative 4. I can put plus or minus the square root of 10 just to simplify, you know, just save a little space. But my y is 0 there. So that's how I'd want to write my answers. When you take your test and your quizzes, I want your answers like this. I want you to start being very precise in the way you write. Okay, so let's quickly try to graph this. And again, you need to be able to do all of this stuff on your quiz and your test. That's part of the deal. You may have to really study a lot to get this. First of all, we knew our y-intercept was 0, 6. So I'm going to go put that there. I'll graph in red. Okay, there's the point. And then my vertex was negative 4, negative 10. Well, that's going to be all the way down here. All right, and I need to label that. That's my vertex, and this is my y-intercept. It's not picking up really well with my finger today. Okay, now one of the other things I know when I get my vertex is I know that there is a vertical line through there, and you must graph this. It's called the axis of symmetry. I'll write it over here just for space. And remember, it's the line. Axis of symmetry. It's the line that goes down the middle of your graph. So what you're going to do is you're going to say, okay, if let's say I call my y-intercept B, okay, for some reason. Now, remember that you're going to get asked for a reflection point. And the reflection point goes, okay, if my axis of symmetry is here, and it's in the middle of my graph, and this y-intercept is 1, 2, 3, 4 away on the right side of the axis of symmetry, I can count 1, 2, 3, 4 away, and I'll graph it in red. There's another point right here. It's a reflection point, and we could call that B prime, or a reflection point. Again, this is stuff not in the book, but you got to know it, so I'm expecting you to be accountable for it. The other thing we'd want are x-intercepts. I've kind of gone ahead and put some stuff in the calculator to make this go a little faster. It's about negative 8.7 is one of those x-intercepts, so it would be about, let's see, 1, 2, 3, 4. I'm sorry, if you simplify, it's about negative 7.2, okay? So that means that it's about closer to here, okay? Now, I can go look up the x-intercept, but if it is 1, 2, 3, and just a tad away on that side, the other one is 1, 2, 3, just a tad away on this side, so it'll be about right here. Let me connect those points with green just so you see what the actual graph looks like. Okay, so you're going to come down here. You're going to come up through there. I missed the x-intercept. It should have been like this, okay? Hard to do with your finger on an iPad, but anyway. It's a very crooked parabola, but that's what the parabola looks like, and those are the important points. And again, you would need to be able to do all of this on a test. You're going to be asked for the reflection point at certain points. You're going to be asked for what the axis of symmetry is. The axis of symmetry is a vertical line, so it's x equal, and it goes through the vertex. The x-coordinate of the vertex was negative 4, so it's the line x equal negative 4. You must know how to write that. It's very important.